Section 3.5 is about scatter plots and trend lines, again dealing with functions and relationships. So a scatter plot is just a graph with points plotted to show a possible relationship between two sets of data. Just because you have a scatter plot does not mean there actually is a relationship. So for example 1, it says the table below shows the number of hours students studied and what their grade was on a test. So theoretically there should be a relationship between the number of hours you study and your grade that you get on a test. The more hours you study, the higher your grade. The fewer hours you study, the lower your grade. So we're going to create the scatter plot by plotting these ordered pairs right here. So we don't have any numbers on these axes, so we have to create our own reasonable scale. So because the hours studied goes from 1 to 20, and we need to determine what's the independent variable versus the dependent variable. Since your grade depends upon the number of hours studied, that means that hours studied must be our x value or independent variable, and your grade must be our y value or your dependent variable. So x is going to go here and y is going to go here. So if x goes from 1 to 20 and we have 1, 2, 3, 4, 5, 6, we can't divide 20 by 6, but we can divide 20 by 5. So I'm going to let this be hours studied. And then we're going to have this be 0. This is going to be 5 hours, 10, 15, 20, 25. And then this over here is going to be your grade. And because your grade goes up to 96, we don't want this to go from 66 to 96 because that would be deceptive. We have to go from 0 to 96, so why not go from 0 to 100? So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I'm going to label every other one. So this is going to be 20, 40, 60, 80, and 100. So I'm going to plot our points. I'm just going to be, approximate. So 1 hour study gets you 66. So that would be, right about here. 4 hours studied is 71. 6 hours is 75. 10 hours is 79. 12 is 83. 14 hours is 85. 15 hours is 86. 18 hours is 91. And 20 hours is 96. So this is what's called a positive correlation, because as the number of hours studied increases, your grade is increasing. So if both things that you're comparing move in the same direction, increasing, it's going to be positive. So this is positively sloped because as the number of hours studies increases, your grade increases. Conversely, if the number of hours you study decrease, so if we go down, your grade is going to go down. So because they are both moving in the same direction, this is a positive correlation. And we can draw what's called a trend line or a best line of fit. And we typically like to make sure that we include half of the data items above and half of the data items below. So I would probably draw my line of fit somewhere through here. Okay, next. So we just started talking about correlation. And so I already talked about the positive correlation with the last one. There are 3 types. With positive correlation, both sets of data values increase, or both sets of data decrease. Remember, it can go in both directions. So as your hours studied increase, your grade's going up. But as your hours of study decrease, your grade is going down. So they're both going in the same direction. Whereas negative correlation means that one set of values is going to increase and the other set of values is going to decrease. Note that this is now tilted in the opposite direction. So as elevation increases, our mean annual temperature is decreasing. So as elevation increases, our temperature is decreasing. They're at war with each other. They're going in opposite directions. Same thing can be said as elevation decreases, the temperature is going up. So as elevation decreases, the temperature gets gets warmer. So that shows your negative correlation. And then no would look like a big swarm of mosquitoes. There is no relationship between the two items. So we can always graph two different items and look at their relationship. That doesn't mean that there is one. So here we've got your birth month, January through December, and then your height. Clearly, the month that you're born in does not determine your height. So this shows no correlation. It's just a big cloud. We have no way to determine where we would put that best line of fit. And then let's see if you can identify the correlation. So stop the video and determine with example 1, 2, and 3 whether it's positive, negative, or no correlation. And explain. So for example 1, the number of empty seats in a classroom and the number of students seated in the classroom. So as the number of empty seats in the classroom increases, so we get more empty seats, the number of students seated in that class would theoretically decrease. So because they're at opposite, one's increasing and one's decreasing, this is a negative correlation. Example 2. The number of pets a person owns and the number of books that person read last year. There is no correlation between the number of pets a person owns and the number of books a person read. As your pets increase, that doesn't mean that your books you read increases or decreases. There's just no correlation. So this one is no correlation. Then example 3, the monthly rainfall and the depth of water in a reservoir. So as your monthly rainfall decreases, the depth of the water in the reservoir would decrease as well. There wouldn't be as much. Conversely, if the monthly rainfall increased, then the depth of the water in the reservoir should increase as well. Because both things that we're comparing are going in the same direction, this is a positive correlation.